Hi everyone, I'm going to solve the following exercises on radicals in this video. So first of all, I'm going to simplify these expressions, then we're going to learn how to rationalize the denominator of a fraction. And before that, what is meant by rationalizing the denominator of a fraction. If we have something like that, we cannot add the radicals unless they have the same radicand. So for example, if I have something like 3 square root of 6 plus 8 square root of 6, we can add the coefficients and this becomes 14 square root of 6. So we do not add the radicands, we do not add the numbers underneath the square root, we only add the coefficients, 3 and 8 in this case. If we look at this example, all the radicands are different. So in this case, we will have to simplify the radicals. We will have to break down these numbers underneath the radicals so that we might find some common radicands. So how do we do that? I'm going to break it down into the product of prime factors. What is meant by that? Let's start with 50. What we have to do in the beginning is to write 50 as the product of any two numbers. So we can say that 50 is 2 times 25. If we get any prime number, we circle it. Again, what is meant by a prime number? A prime number is a number that cannot be divided except by 1 and itself. So 25 is not prime. So we keep breaking it down. So 25 is 5 times 5, and 5 is prime. So we circle these two numbers. So we end up with the square root of 50 being equal to 2 times 5 to the power of 2. And 5 to the power of 2 is a perfect square, which means we take it out, and the answer becomes 5 square root of 2. Now let us do the same thing for 200. So 200 is 2 times 100. We circle the 2. 100 is 2 times 50. We circle the 2 again. And 50 is 2 times 25. Finally, 25 is 5 to the power of 2. So we end up with the square root of 200 is equal to the square root of 2 squared times 5 squared times 2. So we can take out both 2 and 5, and the final answer is 10 square root of 2. We now come back to our expression. So 3 square root of 50 is 3 times 5 root 2 minus 4, the square root of 80. If we do the same thing, we end up with 4 times the square root of 5. 200 is 10 root 2. 5 square root of 180 is 5 times 6 root 5. And finally, the square root of 121 is 11 because 121 is a perfect square. So we continue the work. So this becomes 15 square root of 2 minus 4 times 4 is 16 plus 10 root 2 plus 30 root 5 minus 11. Now we look for the terms which have the same radicand. So we have this and this, as well as this term and this term. So 15 root 2 and 10 root 2, we add 15 and 10 becomes 25 root 2. Negative 16 root 5 plus 30 root 5 is 14 root 5. And finally, we copy the 11, and that's the simplest answer. For the next exercise, we have to distribute, we have to multiply. Now, first of all, how do we multiply square roots? If I have a root b times c root d, I multiply the outer numbers together and the inner number together. So this gives us a times c square root b times d. So let us apply it on our example. 3 root 5 times root 5, that is 3 square root of 25, because we have 3 times 1 is 3 and 5 times 5 is 25. Then 3 root 5 times 7 root 2 is 21, and 5 times 2 is 10. 4 root 2 times root 5, that is 4 root 10. 4 root 2 times 7 root 2 is 28 square root of 4. Now 25 is a perfect square, so it becomes 5. 10 remains as is, we cannot take out any factor of it. And finally, 4 is a perfect square, so it becomes 2. So the final answer is negative 41 plus 17 square root of 10. For the next exercise, we are asked to rationalize the denominators of the following fractions. Now, first of all, what is meant by rationalize the denominator or rationalize an expression? To rationalize an expression, this means to convert it into a rational number. In other words, to get rid of the square root. So for example, in the first fraction, we have a square root of 5 in the denominator, which is not a rational number. So we need to convert it into a rational number. That's what is meant by rationalizing the denominator or rationalizing any expression. This means I have to multiply each fraction by a factor which converts an irrational number into a rational number. And this factor we're going to multiply is called the conjugate. So for the first example, which factor that I multiply by root 5 and gives me a rational number is simply itself. So if I multiply root 5 by root 5, the answer is 5, which means I have to multiply by the square root of 5, but of course I cannot multiply only the denominator because the question will change. I have to multiply up and down by the same factor, and this becomes 3 times the square root of 5 is 3 root 5, and root 5 times root 5 is the square root of 25, which is simply 5, and we've rationalized the denominator of this fraction. For part B, again, we have to look for a factor which is called the conjugate, so that we'll be able to get rid of the radicals from the denominator. Now, if we have a factor with 2 terms, then the conjugate happens to be the same factor but with an opposite sign in the middle. So if we have a plus, we have to convert it into a minus, and vice versa. Which means I have to multiply up and down by 2 square root of 2 minus the square root of 3. This is our conjugate in this exercise. Now for the numerator, I just expand. For the denominator, this is a plus b into a minus b, and this will give us a difference of 2 squares. So we have to use this identity, which means we can right away write it as 2 root 2 squared minus the square root of 3 all squared. So we get this expression, and yes, we were able to get rid of the square root in the denominator. This means that we are on the right track, and it becomes 15 minus 5 root 6 over 5. Now, is this the final answer? No, because we can still simplify. But of course, I do not mean doing this. That's wrong. So we cannot simplify like that because we have a minus in the middle. What do I do then? Well, I factor a 5. So I am left with 3 minus the square root of 6 over 5. And now we can cancel the 5s. Why? Because we have a product here. And this is a very common mistake. So again, we never simplify if we have a minus or plus in the middle. Thus, the final answer becomes 3 minus the square root of 6. What about part C? Now this is a cubic root. If we multiply up and down by the cubic root of 7, this is not going to do the work. Why? Because if you look at the denominators, 7 square root of 3 means 7 to the 1/3. If you multiply it by 7 to the 1/3, that is a 7 to the power of 2/3, and this is what? This is the cubic root of 7 squared, that is a 49. So we are still stuck with the radical, which means this is not the conjugate in our case here. So what do I do? Well, I have to multiply by a factor which converts it into a 7 to the power of 1. And this is achieved when we multiply by 7 to the power of 2 over 3. Because when you add the exponents, you will end up with 3 over 3. So we have to be careful here. It's not always the case that we multiply by the same radical. It is only the case if we have a square root like this. So we multiply up and down by the cubic root of 7 squared, and this gives us 5 times the cubic root of 7 squared, that is a 49, and this, as we said, becomes the cubic root of 7 to the power of 3, which is 7 to the power of 3 over 3, and that is a 7. Finally, for part D, again, this is another common mistake. We cannot multiply by the cubic root of x plus 1 up and down. This doesn't work. It only works in the case of a square root. So what do we do here? Well, our goal is to convert this term into something like the cubic root of x, all of it to the power of 3, in order to be able to cancel the radical. How does this happen? This happens if we use the following remarkable identities. So this is how the conjugate term looks like in this case. Thus, we will regard this as a and this as b. So we have a minus b. So we have to multiply up and down by a squared, that is the cubic root of x squared, plus a times b plus b squared. So this is the conjugate if we have cubic roots. So now the top becomes just the cubic root of x squared plus the cubic root of x plus 1. And the bottom is what? It is a minus b into a squared plus ab plus b squared, which matches with this identity. So we get the cubic root of x all to the power of 3, and this is the a cubed, minus 1 to the power of 3, and this is the b cubed. So the final answer becomes like this. And yes, we were able to get rid of the radical.